Alright, the pageant of rational expressions continues. Now they're saying simplify, and they're giving us fractions which need to be added together. And you will remember, if you want to add fractions, their denominators must match. These do not, so we have some work to do before we even get started. This first fraction contains a 2x. This one does not, so to fix that, we put a 2x in the denominator and a 2x in the numerator. It doesn't matter all that much if you put them in on the left side or the right hand side. Where I can, I will put them in the order that I like, where you have numbers first, then single variables, then binomials, then trinomials, and so on. Where I have to, where I'm hurting for space, I'll just wedge them in wherever. So we have our 2x. Now this fraction contains an x minus 4, so this one requires an x minus 4 as well. And here it is. This x minus 4 multiplies the entire numerator, both terms, which means there's probably some foiling in our future. Actually, there's foiling in our future right now. I have to expand this. The result, when we multiply all that out, is going to be over 2x times x minus 4. Right? The whole point of changing these was to get these denominators to match so that we could combine the two fractions. And upstairs we get x times x. We get a minus 9x and then a minus 4x. We get negative 4 times negative 9. And then here we get 3x times 2x, which makes 6x squared. And the last thing we can do to clean that up is, here we have an x squared and then 6 more x squareds. Grand total of 7x squared minus 13x plus 36. And the denominator is unchanged. Okay, these aren't all divisible by 2, so I can't cancel that. They don't all contain x's, so I can't get rid of the x. I don't believe there's any connection to x minus 4, so we'll leave that alone as well. So all that remains is non-permissible values. Looking at this, each of these individual pieces could equal 0, and those are the things we have to rule out. So if we do x minus 4 cannot equal 0, that gives us the non-permissible value x cannot equal 4. If you take the 2x or just the x, doesn't really matter, you get x cannot equal 0. And the 2 you can pretty much ignore. 2 can't ever equal 0, so there's no need to worry about it. So our non-permissible values are 0 and 4. Next one. Now our common denominator, well, it's going to be both of these terms. This first fraction contains a 2y plus 5, so the second part needs 1. And I have to put it in top and bottom. The second fraction contains y minus 3, so the first requires a y minus 3. And so we get 4 times y, 4 times negative 3. Now this negative applies to both of these. We get negative 1 times 2y. And we get negative 1 times 5. That's not the only way to handle the negative, but it's the way I'm used to. If you do something different, as long as you end up with these same terms, then you're doing fine. And, you know what? Just so I don't mislead you, I forgot to write in the y minus 3 in the denominator here. Of course it had to be there, but I just want to make sure you don't, just so you don't think that I had some devilishly clever way of circumventing this, I simply forgot to write it in. I put a y minus 3 in the numerator. I should have put one in the denominator as well. And this whole fraction ends up being over y minus 3 2y plus 5. Now, cleaning up the numerator. 4 y's, you lose 2 of them, you have 2 y's left. Minus 12 minus 5 is a total of minus 17 over y minus 3 2y plus 5. If this had a common factor, the numerator, I would pull it out, but since it doesn't, that's the end of the simplifying steps. For non-permissible values, I have to look at these two pieces in the denominator. The y minus 3 bit cannot be allowed to be 0, therefore y cannot be 3. And for the other bit, 2y plus 5 can't be 0, which means 2y can't be negative 5, which means y can't be negative 5 over 2. Last one. Now we need another common denominator, of course. This first fraction contains an x minus 5. And we need an x minus 5 up here. Again, remember this x minus 5 applies to the entire fraction. You probably want to put in brackets to remind yourself of that. And the second fraction contains an x plus 1, which means the first needs an x plus 1. More brackets. And, of course, x plus 1 downstairs as well. So, we're going to get one big fraction with the denominator of x plus 1, x minus 5. And in its numerator, I have to FOIL this, and I have to FOIL the second part. X times 2x. X times 1, it's the outside. Inside is 1 times 2x. Last is 1 times 1. Now, this negative right here applies to everything from this set of brackets. So I'm going to be foiling and then throwing in negative signs just to try to do this in one line. X times x is x squared. Then attach a negative, it becomes minus x squared. Outside, x times negative 5 makes negative 5x. But then this sign changes it around to plus 5x. Inside, negative 4 times x is minus 4x. This flips it around to plus 4x. And finally, negative 4 times negative 5 is 20. Attach this sign and you get minus 20. Whew. Okay, now when we clean this up, collect terms. 2x squared minus 1x squared leaves 1x squared. X plus 2 more makes 3 x's. Another 5 brings us to 8x, and another 4 brings us to 12x. And then we have 1 take away 20 makes minus 19. And that's all over x plus 1, x minus 5. We'd factor this numerator if we could. I don't believe there are any numbers which can add up to 12 and multiply to minus 19, so that's a dead end. Non-permissibles. X plus 1 must not equal 0, which translates to x can't be negative 1. And for the second bit, x minus 5 must not be 0, therefore x can't be 5 either.